Cool. All right. So, sorry about that. So if you just start up a basic Sinatra, so this is Ruby. I don't know how many of you guys are familiar with Ruby. It's really easy to understand language. You can kind of just look at it and read it like English, and it'll usually do whatever you think it does, which is pretty cool. So here we see this is just a really basic start of a web server. If I do a GET request to /hello, it'll respond world. And if I just go to /, it'll give me Taco Bell. So then let's just make sure that this is doing what we think. So then we see world. Cool. So then I've already done all this in advance, and I'm going to be kind of fast forwarding through what I did earlier. I'm just going to be checking out different commits throughout my history here. So then let's see if my server is going to restart. Cool, so we're up. And then if we go back, then we can see we have the Taco Bell menu now. So this just kind of magically appeared here. Let's see if we can find how this works. So let's refresh this. Okay, so now we have this Taco Bell method. And if you can see down here where my mouse is, we have getting the / will run this method Taco Bell, and then it will put all of the things in a list with the item and then the price. So inside Taco Bell here, we're going to this URL, opening it up, and then this is using a gem called Nokogiri, which is awesome. It basically just simulates opening this web page in a browser, and then you can use CSS selectors to select different elements around the page and then see what's inside them. CSS selectors are used in a bunch of different things, primarily web development and CSS, hence the name. So basically, this is just going through a bunch of rows here, and then it's getting different columns and putting that information into this big menu. And then that is showing up online. So that's pretty cool, but we don't have any of the nutritional data yet, and that's kind of important because we want to know what the best is, what the best combination of things is. So I'm going to skip ahead a little bit here and wait for the server to restart. So what's going on right now with this, you can see this rerun here. This is just a little Ruby gem that watches anytime I change a file, it'll restart the server. So that way I don't have to keep like Control-C and then run the last command and everything. So I'm not sure if this one has any, okay, so this one we start to get the space for it, but we don't have it yet. So let's see what we have in the code now. So if we refresh this page, okay, so now we've added some classes here. So there's a class called menu item, and every menu item will have a name, price, calories, and protein. So this is cool. Same content, just a little bit more structure to it. So then let's go ahead and skip ahead some more. So this one should add the nutritional info. And then again, we're going to wait for this to restart. So, okay, so now if we go over to the website and we refresh this, then we can see here. So some of these have calories and protein, like the Crunchy Taco does, but the Crunchy Taco Supreme doesn't. So this is because the website that it's pulling it from, the names don't match up exactly. So we're going to come back to this in a minute and fix it, but I just want to get the basic stuff done first. And let's go ahead and take a look at how we're doing this. So now inside this menu item, we have this method called get nutritional info. So what this will do is it'll go to another URL, and again, using Nokogiri, it'll go through all of the rows in this table, and it'll say, okay, if the name of that equals the name of this menu item, then I can copy down the calories and the protein. And you can see this is just Taco Bell's website /nutrition/information. So this isn't some like magical source I made up. This is just tacobell.com. So let me make sure there's nothing else changed in here. Yeah. So we still have the same overall structure. So we're going to Taco Bell to get the menu, And then as soon as we find a menu item, we're going to populate the nutrition facts. So then we can see those on here. Cool. So now we saw that a bunch of these don't have the nutrition information attached to them. And that's kind of annoying. So what we're going to do is add something called fuzzy matching. So while we're waiting for this to restart, I'll say what fuzzy matching is a little bit. As you might be able to guess from the name, it basically takes two strings and it says what percentage of a chance is it that these are the same thing, or how similar are these strings, might be a better way to say it. So that's from 0 to 1, and if it's 1, they're the exact same string. And if it's somewhere in between, then it is like so far away from it. So like if you change one character, it might have 0.9 instead of 1.0 now. So if we go into the code here, then we can see where we're adding nutritional info. All right, right here. I zoomed in, there we go. So this is again using this gem called fuzzy string match, just some random gem I found online. And now instead of saying if that row element in the Taco Bell website equals what I'm looking for, I'm going to say if the distance is greater than 0.8. So I'm going to say that if there's if that distance between the two strings I'm comparing is greater than 0.8, then it's probably just like some parentheses that are missing, or like an S, or like something like that. So there's a really high chance that they're actually the same thing, and that's what I'm looking for. So now if we go back and we refresh this page, it's going to have to rebuild some stuff. Now we can see we have information for everything, or almost everything at least. So we now have the calories and the protein for pretty much everything, and we have the price. So now this is looking really good. So now, just conceptually, what you're going to do, or what I'm going to show you, is if you take this and you say, I have $10, it's going to sort this by the things with the most calories, and it's going to say, okay, how many of the most caloric items can I fit in? So if the most caloric thing costs $3, I'm going to be able to fit 3 of those in, and I'm going to have $1 left over. So I'm going to keep going through this list and find something that only costs $1 or less, so I can maximize the amount of calories I can get. So that will be in the next version. So let's go ahead and skip forward there. So this is kind of a variation of a problem in computer science called the knapsack problem. So if you see my commit message here, it says a pseudo knapsack algorithm. That's because a real knapsack problem is a lot more complicated, and you have to like take into account a bunch more things. But this is a really easy and quick way to do it, and it's not the most efficient, but it's pretty good for what we're doing. So here's the method that does that. If I can center it. All right, so we say it's best for. So we take a wallet, which is like the $10 that you have. And then we're going to say our running total is 0. We haven't added anything to our bag yet, our knapsack, if you will. So then I'm going to go ahead and sort. This big long string here is just going to sort by the calories. And then I'm going to run through each sorted thing, and I'm going to say, while the running total plus the price of this item is less than my wallet amount, then I'm going to add it to my sack and update the running total. So if it sounded complicated when I said it earlier, I hope you can see now it's really not. It's just 5 or 6 lines of code. And it basically just runs through and adds as many of everything as it can in the order of calories. So now if we, and in here, we have also now, let me go down to the bottom here. So before we had get slash, and we also had hello. That's gone now. That was just for like seeing if it worked. So the slash still does what it did before. It just prints out the whole menu. But now we have this one that's called best for. And the idea is like it's best for calories or best for protein or whatever. So right now we're just doing calories. We're just trying to get this working. And we can see that we now have this get slash best for. So I guess I didn't cover this in the beginning. If you guys don't know, a GET request is a type of HTTP request that happens when you just go to a website in your browser. So anytime you go to google.com, that sends off a GET request to google.com. There's also post, patch, a couple others. Get and post are the two most popular. So here we're going to use get, and we're going to say if you go to /best4 and give it a parameter called wallet. So this is just a number. We're going to convert that to a float, which is just like a number with decimal places. Then we're going to call this method that I just showed you up here, the best4, and we're going to print all of them out. So if we go over here, so the root is still going to take me to the same place. Oh, I formatted it as a table now, so that's kind of nice, nicer to look at. And so now if we go to best4 and we say wallet, oh, sorry, I'll zoom in on this. Okay, so yeah, I did it before. Wallet equals 15. Bam. Now, best for $15, you get 2 grilled stuffed burritos, beef, crunchy taco and large drink. That's a combo meal. And you get 870 calories for each of those. And then you can get a grande scrambler as well, probably only at breakfast. I didn't take into account the whole different menus thing. Some other time. So that will add up. I guess I should have a total in here somewhere, but that'll add up to less than $15. So this means you can walk into Taco Bell with $15. This takes tax into account, Indiana tax. You walk in with $15 and walk out with, what is this? This is like almost 2,000 calories. It's pretty good. So now I skipped over a couple things. So right now this only does calories, and it only does in the browser. So I told you earlier that I was going to talk about Twilio, and I will get there very soon. So here we have a switch for between protein and chicken. That's a typo. That was supposed to be calories. I was working with a lot of food things, I guess. So now we're going to add in Twilio support. So we're going to check out this commit. If I can type. And then we're going to wait for the server to restart. So Twilio, the way it works is you can go to twilio.com, and I don't have it up anymore, but Greg from Twilio hooked us up tonight. So next time you see them at Hackathon or whatever, go up and say thanks for supporting Purdue Hackers. And so if I go into Dev Tools here, so here's my Twilio number. I guess I can make this a lot bigger. And if I go into my apps here, you can see I called this bulk mode. And whenever you send a message, a text message to this, it'll send a post request to this URL. And this is ngrok. I'll talk about ngrok in a second. But basically, ngrok will forward through requests to my local computer. So even though this isn't like a web server or doesn't have a website or anything, I can just run this little program called ngrok, and it'll forward everything through to my computer. So Twilio, as soon as you send a text message to them, they'll make a post request to my server, which in this case is my laptop right here, and it'll have the body of the message. So if you send a text message, here, you guys can actually try this. Where's my phone number? There. So if you guys send a text message to this number with if you send a message to that with the dollar amount, and I don't think this supports the protein versus calories yet, but you send it a text with 15, and it'll send you a response with 2 grilled stuffed burrito meals and a grande scramble, I believe. There we go. We getting it? Cool. So now we can see. Oh, here we can see in the web server here all of these requests coming in. So 10,000. I have not. Whoever did 10,000, let me know what comes back. It's probably really long. 10,000 it crashes. Oh. You can tell that I wrote this 4 hours before this. 100,000? Did you get anything cool with 100,000? Oh, yeah. So did anybody get anything interesting? No? You either crash my server or crash my server. All right, cool. So now we can check out how the Twilio stuff works in here. So we can see now, I told you earlier that if there's get and post requests. So now Twilio sends a post request to my server. So that's what we see here. So then here on line 114, I'm sure you guys can't see it, but it sends me the body of the text message. So now I'm going to split that on spaces. And the first one is going to be the dollar amount. And the second one is going to be either calories or protein. And then it's going to say, you should buy. And then it's going to say all of these things with the word and in the middle. And then it's going to put that into some XML here in this response. And it's going to, Twilio is going to get that response. And then it's going to turn around and forward it to all your cell phones. So yeah, that's really it. I mean, you saw online on the Twilio site here, I just had, where was it? Forward a couple times. Yeah, so I just put this URL in there, and then I accept that and give an XML back, and it will do text messaging. So I think that's pretty cool. Oh, ngrok. So here's ngrok. And basically, like I said, this will take an external request and forward it on to my computer. So like we can see here, it just generated this URL for me. So this is what I put into, whatchamacallit, Twilio. Average connection time, 390 milliseconds. It's not bad. Okay, so I think that is all that I had implemented. Yeah, so you can now parse through websites, pull out information you care about, format it in a table on the website, and respond to text messages, all with Ruby and Sinatra and Twilio. So Sinatra is really awesome. You just define a bunch of methods that just say get to whatever URL, post to whatever URL, and then you return whatever it is, and that's really all there is to it. This entire program is 137 lines long, and yeah, that's basically it. So I'll be sitting around if you guys have any more questions for me, or do you have any questions now? Did I go anything too fast, or? My favorite thing at Taco Bell? It's a chicken quesadilla, of course. It's a classic. Yeah. So the knapsack problem is a problem in computer science where you have a limited space. So like the problem is usually posed in this way. So I'm a traveler traveling around the world. I have a knapsack and I want to fit the best things that I can into it. So I have a limited amount of space, and everything that goes in there has some amount of space it takes up, and it has a value. So food has a high value and a medium space, and clothes have a low value and a high space. So I want to write an algorithm that will optimize and get me the best value given some space constraint. And this is a very, very loose version of that, where we have some dollar amount, which is like the space of the bag. And then we have all of these things which have some value and some cost, like some space they take up. And we're trying to fit the best ones in. So in the real version, you have to go through, because there's usually more than one criteria. And I don't know, I don't really understand the real version, to be frank with you, but this one's not bad to implement. Good question. Anybody else? All right. Well, if that's it, like I said, I'll be sitting down here. Oh, Grant? Oh, okay. Cool. Yeah, so without further ado, here's Grant to talk about things.
We're going to work on our hand signals. I forgot, like, the telepathy wasn't working today. Anyways, my name's Grant Kamina. Sorry I couldn't be here at the beginning of this event. I'm the student lead over here at the Anvil. If you guys aren't familiar with us, we're student founded co-working space here on campus at Purdue, dedicated to really building the student startup culture on campus, as well as like doing events like these and creating an environment like this where people like